Hello, chemical systems. So hopefully you guys have just gotten back from watching this video about hydrogen and oxygen gas reacting. So some of you, some of you may know that water is made of hydrogen and oxygen, and by itself, hydrogen and oxygen are normally gases. And so what this guy did is he put hydrogen in a hydrogen gas in a little tank, and he lit it. And with quite a surprise, it exploded. Probably not a surprise to him. But anyway, so that is the synthesis of water molecules. Today you're going to learn about what synthesis reactions are. But the whole point of this video is to get you guys introduced to chemical reactions, what chemical reactions mean, and what we use to explain them. So last week we went through chemical formulas, how chemical formulas are written, and this week we're going to look at chemical equations, which describe how reactions take place. So what I want to do is I want to show you what was actually going on inside this little can here, this can of hydrogen gas, which, as he describes in the video, becomes combined with oxygen gas. If you haven't watched the video, go and do that real quick. It's on the agenda. But inside the tank, he has hydrogen gas. Now, hydrogen gas isn't just a bunch of lonely hydrogen atoms. So hydrogen atoms by themselves aren't very stable. But when we put them together, now we have a stable hydrogen molecule. Remember, molecules, two or more atoms when they're joined together. So we have our hydrogen molecule. Same with oxygen. Oxygen isn't just by itself as individual atoms, but they're together. They want to be together to complete their valence shell of electrons so they can complete the octet, or so they can have 8 electrons, or at least pretend to have 8 electrons in their valence shell. So hydrogen and oxygen, when combined with enough energy, can form water molecules. But even looking at this picture, you should see that something is weird here, because if you start with oxygen gas, oxygen gas is a molecule of 2 oxygen atoms. Well, one stable water molecule has only 1 oxygen atom. So where's the extra atom coming from? Well, let me use this simulation to show you. So here I have a blank container, and I'm just going to fill it up with some hydrogen gas. 1, 2, 3, 4, 5, 6, 7, 8, and some oxygen gas. 1, 2, 3, 4. Okay, so now I got hydrogen and oxygen floating around together. And let's say I light a match. I'm going to click on synthesis. This little synthesis button on the simulation is going to force. Oh, well, you just saw it happen. So when you have, there we go. When everything's coming together in the right proportions, the oxygens and hydrogens will kind of switch places. So now each molecule has 2 hydrogens and 1 oxygen. So I was careful at the beginning to fill this up with the right amount of hydrogen and oxygen, because I need double the hydrogen gas. All right, so it's a 2 to 1. Let me just say it's a 2 to 1 ratio. So I need twice as much hydrogen as I do oxygen in order to make water. Let me just reset this and show you, for example, what happens if I add 2 hydrogens, 2 oxygens, and then click on synthesis. What's going to happen is that I have 2 water molecules and 1 oxygen molecule. There's no hydrogen to pair up with that one, because again, I need twice as much hydrogen in order for this reaction to take place. But we're going to get more into numbers later. I just want to show you what's going on inside the can. This simulation is kind of cool because I can also press decomposition, which allows the oxygen to come back together and hydrogen to come back together to form their individual gases. And this is another type of reaction. So we just watched the synthesis of water, but you can also decompose water through something called electrolysis. If you run a current through water, an electrical current through water with the right setup, you can actually separate water into its oxygen and hydrogen gas that first made it. And this is not actually how scientists don't sit in the lab making water molecules all day. This could be done in a lab, but normally our drinking sources come from other places. It would be too explosive and too expensive to just make water this way. All the hydrogen and oxygen that you'd have to collect to do this would be pretty nuts. So that's just kind of an introduction to what chemical reactions look like. We guys are going to be writing some chemical equations this week. I just wanted to make sure you knew what they are representing. And let me just go ahead and show you the chemical equation. I'm going to show you guys this in a different video. If I get Zoom to work, here we go. So here's what the chemical equation actually looks like. 2H2 plus O2 yields 2H2O. So whenever we have a chemical equation, we don't have an equal sign. We have a yield. This right arrow shows that this reaction is going in this direction toward water. I am forming water in this reaction. But I'll come back to this equation later in a different video. And also you guys do the readings before I try to explain too much. Anyway, thanks for watching, and I'll talk to you later.